Welcome to 10-Minute AI. I'm Dr. Jonathan Luckett. Together, we'll unpack big ideas in AI, one quick bite at a time.
All right, so the story of AI this past year has been one of incredible, almost whiplash-inducing contradictions. And to really get a handle on it, we're going straight to the source, the brand new Stanford AI Index Report for 2025. This thing is massive, and it paints this picture of a technology that is somehow both brilliant and totally broken at the same time. So let's jump in and see what the data is telling us. And this slide right here just perfectly nails that central paradox. In a single year, research driven by AI was behind not one, but two Nobel Prizes. I mean, it's solving some of the hardest problems in science, and yet, at the exact same time, the most advanced AI models in the world can still trip over basic logic that a kid could figure out. So, how can both of those things be true? Well, that's exactly what we're going to unpack. And here's how we're going to break it all down. We're going to look at 5 key areas of tension. First, that core paradox, its scientific wins versus its logical fails. Then, the scale dilemma. Who can even afford to build this stuff versus who can use it? Third, its superhuman skills paired with its, super flawed understanding. Fourth, the very real human impact. And finally, how in the world we navigate this new frontier. Okay, so let's dive right into that first paradox. AI's unbelievable wins in the world of science set against its really frustrating struggles with simple logical thinking. I mean, the level of achievement here is just staggering. The Nobel Prize in Chemistry, that went to the minds behind AlphaFold, which basically solved the protein folding problem, a challenge that had stumped biologists for like 50 years. Then, the Nobel in Physics went to the pioneers of neural networks, the very tech that made all of this possible. These aren't small steps, they are massive, world-changing leaps forward. But then you get this. The report is crystal clear. Even with all these amazing advances, you just can't trust these models for tasks that need a guaranteed, step-by-step, provably correct answer. And that's not just a minor issue, it has huge implications. It means you can't really rely on them for high-stakes situations where you absolutely have to be right. So think about it. It can predict the fundamental shapes of life, but it might flunk your kids' math homework. It's wild. Okay, let's move on to our second big contradiction, which is all about the money and scale. Is AI getting more exclusive or more accessible? And the answer somehow is yes to both. So first off, the cost to create the next big thing in AI is just astronomical, and it's only going up. To train a model like GPT-4o, the report estimates it took 38 billion petaflops. That's a unit of computing power so big it's almost impossible to wrap your head around. The simple takeaway is this: building these frontier models is a game for a very, very small club of incredibly rich players. And yet, and this is a huge and yet, here's where the story totally flips. While training costs are blasting into the stratosphere, the cost to actually use these systems, which is called inference, is in an absolute freefall. In less than 2 years, the cost to get an answer from a powerful AI dropped by a factor of over 280. That makes this tech so much more accessible for everyone else to build on top of. And this chart just perfectly shows you the results of that newfound accessibility. So-called open-weight models, the ones anyone can download and tinker with, are catching up to the big, closed proprietary models at a shocking speed. On some key tests, that performance gap shrank from 8% down to just 1.7% in 1 year. The frontier is getting more expensive for sure, but really powerful AI is democratizing fast. Okay, this leads us right into our third paradox, which is all about performance. What can these models actually do? Well, they're reaching superhuman levels, while at the same time showing us some really deep flaws in what they actually understand. I mean, the pace of new releases last year was just relentless. It felt like every few weeks there was a new bombshell. We had the Claude 3 family, which took the top spot on the leaderboards for a while. We saw mind-blowing video from Runway's Gen 3, and then Meta dropped their massive 405 billion parameter Llama 3.1. The bar just kept getting raised over and over. Which, it just begs the question. Are these models truly getting smarter? Or are they just getting better at pattern matching what they've seen online? How do we even tell the difference? Well, on the one hand, the evidence for superhuman skill is just wow. Systems from DeepMind are now solving problems from the International Mathematical Olympiad. That's one of the toughest intellectual contests for young people on the planet, at a silver medalist level. And we've all seen the videos that are getting so realistic, you literally can't tell if they're real or not. But then you test them on something completely new. This chart shows a benchmark called Humanity's Last Exam. It was specifically made with super hard, expert level questions that you can't just find the answers to online. And just look at that score. The very best model got less than 9% right. It just goes to show you, when you take away their ability to just look things up, these superhuman systems can be profoundly dumb. So, what happens when you take this incredibly powerful yet deeply paradoxical technology and just unleash it into the real world? Well, that brings us to the human impact, a story of a massive economic boom, some very real harms, and an absolutely frantic backlash from regulators. First, that boom. The amount of cash pouring into AI right now is just hard to comprehend. The report is full of these massive funding rounds, like XAI raising $6 billion. Private investment is the rocket fuel pushing this whole revolution forward at a dizzying speed. And at the exact same time, you've got governments scrambling to put some guardrails in place. This slide really tells the story. While things have been slow at the federal level in the US, the number of state-level AI laws has just exploded, more than doubling in a single year from 49 to 131. This is the backlash, right? Society trying to get a handle on this thing. And it's really no wonder why. The report is full of examples of real people being harmed by AI this past year. A facial recognition system in the UK falsely accused a woman of shoplifting. A high school student was targeted with fake AI-generated nude images. And of course, AI content was used in disinformation campaigns trying to sway elections around the world. These are not theoretical risks anymore. This is happening now. So, where does all of this leave us? This final part is all about trying to make sense of this contradictory world as we try to navigate the AI frontier. You know, when you step back, the story of AI today really is the story of these powerful tensions. It's getting cheaper for us to use, but way more expensive for companies to build. It's showing flashes of superhuman genius, but failing at basic common sense reasoning. And it's being used as both an incredible tool for scientific progress and as a weapon for harassment and lies. Ultimately, the Stanford report leaves us right here, with this really critical shift in how we have to think about all of this. For years, the main focus was always technical. Can we make an AI do this amazing thing? But now, as these systems get more and more powerful and more woven into our daily lives, the most important question we have to face is a societal one. Should we? And that's a question that technology all by itself just can't answer.
That's today's 10-Minute AI. I'm Dr. Jonathan Luckett. See you next time for another fast take on the future.